pressure exerted by water at the bottom of the container depends upon the height of the column. Okay, so if we have a container filled with water, then pressure increases with the depth. Pressure increases with depth. Okay, so you can see.
Yes.
So we have an activity here. Here we have taken two tubes, two containers, and you can see water filled in these containers. But water is filled in with different heights in the two containers. In both the containers, we have something attached to it, right? What do you observe? What do you observe?
That in the first photo, in the first picture, the person holding that tube,
Hmm.
uh, it's filled with the half tube is filled with water,
Hmm.
and there's a balloon or what's pressure like what's
So we have something, some rubber sheet here, and we have this water column.
yes.
We have this pipe, and this pipe, one end of this pipe is attached with the rubber sheet, something which is very elastic. Okay,
Mm.
so we can see the amount of bulge here in both the rubber sheet is different.
Yes.
You can see more bulge here where there is more water in the tube. We can see more bulge, and in the tube where we have less water, we can see less bulge. So it means that because we have less water, so it is exerting less pressure on the rubber sheet, and it contains more water, so it is exerting more pressure on the rubber sheet, and therefore there is more bulge. Right? So pressure,
Yes.
amount of bulge in the rubber sheet increases with the height of the water column in the pipe. Thus, the pressure exerted at the bottom of the container depends upon the height of the column. Pressure exerted at the bottom of the container depends upon the height of the column. Okay, in higher classes, in class 11, you will study the formula P is equal to H rho G, where H is the height and rho is the density and G is the acceleration due to gravity. So pressure is directly proportional to H, the height. Okay.
Mm.
Next, fluids exert pressure on the walls of the container in which they are placed. Fluids exert pressure on the walls of the container in which they are placed. Now look at this picture and tell me, what do you observe?
That in the first picture in the first tube, there's no water, and there's a balloon
Attached to it?
and attached to it, and it's uh,
Yes.
in the second picture, the
Mhm. We have
uh,
this
the
container
tube
filled with water.
filled with water, and the balloon is uh, bulging,
Yes. It means that this
like
water, which is present in this container, it is exerting pressure on the balloon and therefore it bulges out.
yes.
So fluids always exert pressure on the walls of the container in which they are placed. See, when we talk about fluids, fluids means something which can flow. Anything which can flow is a fluid. So we say because we know that liquids can flow, water can flow, right? Oil can
Mm.
flow. So we say that these are fluids because they can flow. Are gases fluids? Yes, Lavansh, can gases flow? Do gases flow?
Uh,
Yes.
yes.
Gases are also fluids. As liquids are fluids, in the same way gases are fluids. So when we talk about fluids, we talk about both the gases and the liquids. Okay.
Hmm.
And in this activity, we had seen that when we place fluid in a container, then that fluid exert pressure on the walls of the container. And because this fluid exert pressure on the walls of the container, so this can be seen easily that in the second case, rubber tube bulges out. That is because of the pressure being exerted on it. Okay? Yes. Fluid exert pressure, equal pressure at the same depth. So for this, we can do an activity. And here you can see in this picture, we have a water bottle and we have drilled holes at the same depth. Okay. Now you can see water is coming out through these holes with equal pressure. Because water is coming out through these holes with equal pressure means same pressure has been exerted in these holes due to water. So at same depth, at same height, we have the same pressure, okay, which is exerted by the fluid on the walls of the bottle in this case. In this case, we have water bottle, right? So drill 4 holes all around the bottle at the same height from the bottom. Now fill the bottle with water. Different streams of water coming out of the holes fall at the same distance. All the water streams will fall at the same distance from the water bottle. So it shows that fluids exert equal pressure at the same depth. Okay?
Yes.
At the same depth, we have equal pressure. At the same depth, we have
Equal depth.
We have equal pressure. It indicates liquid exert equal pressure at the same depth. Easy? Should I move to the next slide?
Yes.
Now we have the pressure exerted by fluids increases with depth. What does it say? Can you explain? Pressure exerted by fluids increases with depth. So as we go deeper and deeper, we feel more pressure. Okay?
Yes.
Now, look at this picture. What do you observe?
That there are 3 holes in a container.
But at different heights,
Yes.
at different depths. We can say if we go from the surface to the bottom, then we say depth. We call it depth. And if we
Yes.
measure from the bottom to the surface, then we call it height. Yes, now tell me.
That in the first hole, water like
Tell me. Acha, where do you find more pressure? By looking at these 3 water streams, what do you think? What do you observe? What do you feel? That which
last hole,
water stream is coming out with greater pressure?
in the third hole.
In the third hole. Why in the third hole? Because it is covering.
Because it's covering more because the water is filled up like water is filled up here and it has more pressure of water.
Yes, you can see more pressure because it is covering greater distance. It is covering greater distance. So drill 3 holes in the bottle at different depths. Now fill the bottle with water. Different streams of water coming out of the holes fall at different distance. We can see that we have different water streams. They are coming out of the holes and they fall at different distance. All the liquid have weight. The pressure exerted by a liquid is small, just under the surface of the liquid. So just under the surface of the liquid, just under the surface of the liquid, there is less pressure. But as we go deeper and deeper in the liquid, the pressure of the liquid increases. Okay? And as the depth of liquid increases, the weight of liquid column pushing down from above increases and hence the pressure also increases. Okay? Easy?
Yes.
Yes. Should I change the slide?
Yes.
Next. Next term we have here is atmospheric pressure. So what do you mean by atmospheric pressure? What do you think?
That pressure in atmospheric pressure,
Is the pressure exerted by,
air.
yes, is the pressure exerted by air, is the pressure exerted by atmosphere, is called atmospheric pressure. Okay.
Hmm.
The layer of air around us is called atmosphere. Atmosphere extends up to many kilometers above the Earth's surface. So can you name the layers of different layers of atmosphere?
Uh, Different layers are
What are the different layers of atmosphere? Troposphere, stratosphere,
anos-
mesosphere, ionosphere, exosphere. So these are the different layers of atmosphere. And we have ozone layer present in the atmosphere, which protects us from harmful ultraviolet radiation. Where is it present?
atmosphere.
Oh, in the atmosphere. In which layer? Name.
Ozone layer.
Ozone layer is present in which layer of the atmosphere? Troposphere, stratosphere. I'm giving you four options. Troposphere, stratosphere, mesosphere, ionosphere. Where is ozone layer present?
uh, Troposphere.
Troposphere is a layer where we live in. It is present in stratosphere. It is present in,
Stratosphere.
yes, ozone layer is present in stratosphere. So we have a number of different layers, right? Right? Troposphere, then we have stratosphere and other layers also. So we are covered by these layers of atmosphere. Do we feel pressure? Do we feel pressure of air
No.
exerted on our head? Do we feel
No.
headache due to this atmospheric pressure? No, we do not feel. The pressure exerted by air in the atmosphere is called atmospheric pressure. Okay, the atmosphere exerts pressure, and that pressure is called atmospheric pressure. Atmospheric pressure is the weight of the air in a column of unit area. This is how we can define atmospheric pressure. It is the weight of air in a column of unit area. If we take a column of unit area, you can see the base area. Look at this
Yes.
unit area. Okay, if we have a column of unit area, then weight of air is the atmospheric pressure. Here we have something, a rubber sucker pressed on a surface. What happens?
Rubber sucker pressed on a surface. Then it will stick to it
It will stick to it. Why?
because of air pressure.
Because of air pressure, it will stick to it. When you press the sucker, most of the air between its cup and the surface escapes out, and the sucker sticks to the surface because the pressure of atmosphere acts on it. To pull the sucker off the surface, the applied force should be large enough to overcome the atmospheric pressure. So we need to apply so much effort to pull it, right? Because
Hmm. Because there's pressure on it.
because there is pressure on it, there is atmospheric pressure on it, and air inside the sucker escapes out when it is stick to the surface. When it sticks to the surface, air, most of the air
Escape.
between the cup and the surface escapes out. So there is very less air. There is very
When
less
it's
air. There is less air, and sucker sticks to the surface because of the atmospheric pressure acting on it. So we need to put so much effort to pull it. Yes.
okay. Yes.
Next, pressure of atmosphere on your head. Why don't we feel that atmospheric pressure on our head?
Because the atmosphere absorb all the pressure.
No, doesn't make sense. See, the pressure exerted by atmosphere is tremendous. We are not crushed under it because the internal body pressure is equal to the atmospheric pressure. So both the pressures cancel out. Okay, atmospheric pressure is tremendous. It is huge, but it is balanced by the internal body pressure of ours. And both the pressures cancel out in pairs. So we do not feel any pressure on a head. Okay.
Okay. Hmm.
Now give reasons. Mountaineers sometimes have nose bleeding. Why?
Uh,
When we go to
because
height,
they are
then
on a height. Because they are on a height due to air pressure.
yes, and
As
air pressure
uh,
reduces when we go to heights, but our internal body pressure remains the same. It will not change, right?
yes,
When we go to heights, air pressure reduces, but our internal body pressure remains the same. So outside pressure is less than the internal.
then
External pressure is less than internal pressure. External pressure is what? External pressure is
uh,
the atmospheric pressure.
yes,
Internal pressure is the,
body pressure, our body pressure.
yes, and this is the reason they bleed. So as we go up, atmospheric pressure decreases, but our internal pressure remains the same. And due to this internal greater pressure, some blood vessels burst and nose bleeds. Easy?
Yes,
Next, astronauts wear special suits. Suits?
uh, because there's zero gravity in
Because there is
zero gravity.
zero gravity in space. Okay. And what else?
There's no air pressure there because
Because there is
atmosphere.
no gravity and therefore there is no atmosphere. Okay.
Uh,
Then what happens?
uh,
No gravity, no atmosphere is clear.
and their body weight, uh,
Body
body
pressure.
weight, body pressure is uh, more than greater than the uh,
Yes.
like because there's
Because their body pressure is greater. So the body will burst due to internal body pressure if they won't wear this as special suit. Because there is no atmosphere in space, and to maintain the pressure around the body, astronauts wear special suits. Otherwise, the body of the astronauts will burst due to the internal body pressure. Next question. Rubber suckers stick to a smooth surface. Why?
mm, because when we put the rubber suckers, the air present outside goes the in the space of like goes
Air,
inside
air inside escapes out and it sticks to the surface. And
yes,
outside the rubber sucker, we have air pressure. Air pressure is exerted on the rubber sucker, and due to this, it sticks to the surface. When you press the sucker, most of the air between its cup and the surface escapes out. The sucker sticks to the surface because the atmospheric pressure acts on it. Yes. Next question. Do not get crushed under atmospheric pressure. Why?
because
Because
because our
yes,
atmospheric pressure is and our internal pressure is the same.
yes, because it is balanced by the internal body pressure. We do not get crushed under atmospheric pressure because the internal pressure of a body is equal to the atmospheric pressure. Next question. Walls of a dam are built broader at the top, bottom than at the top. Have you seen dams? Have you ever
Uh,
visited? No?
like when I was small, I seen them, but I didn't remember.
See, walls of the dams are constructed in a way that they are broader at the bottom than at
I
the
have
top. They're
seen.
like this. Why? Broader at the bottom than at the top. Why?
Mm,
See, we had read now that pressure increases with depth as we go deeper and deeper. We feel more pressure.
yes.
This might be the reason
Yes.
that the wall of the dam is broader at its base because the pressure exerted by liquid increases with increase in depth. The dam contains huge amount of water. As we go deep, the pressure exerted by such a huge amount of water increases to very high, right?
Hmm.
Next question. Rails on railway track are fixed to large and wide wooden or steel sleepers. Have you ever traveled by train?
Yes.
So have you observed the railway track? How does it look like? There are wooden
It's
planks and the rails.
the rails are of iron.
Yes, and we have wooden or steel sleepers.
Yes. Yes. Steel.
So why they are fixed to large and wide wooden or steel sleepers? See, we can have those simple railway track. No? Hmm?
Yes. So that wood cannot uh like
Yes.
so that wood cannot bear the pressure of the railway train.
Hmm. Because it is huge, it is heavy, it exerts a
Yes.
lot of pressure on the
Yes.
railway track, and this is the
Yes.
reason they are fixed to large and wide wooden or steel sleepers to reduce pressure received from the train by increasing the area of contact.
Hmm.
If the surface area increases, then pressure decreases.
Yes.
And how do we relate mathematically pressure, force, and area? What is the mathematical relation between these three? Formula for pressure is
Uh, for pressure is force by
area.
yes, area.
Pressure is force upon area. So if area is increased, then pressure will decrease.
Decrease.
Larger the
Yes.
area over which the force acts, smaller is the pressure exerted. And this is the
Like
reason. Hmm?
I've seen this like when we will stand on a egg, then it will break, and if we will stand on a like egg tray, full egg tray, then
Hmm?
will not break because pressure is uh, because
Yes.
area
Area becomes
uh,
greater and pressure is reduced.
reduced.
Next question, a heavy truck or a lorry carrying heavy loads has 8 tires instead of 4 and the tires are broad. Why?
Due to so that they can uh, bear pressure, and if there will be no tires, then due to pressure of the heavy loads, it can
First,
uh, uh, yes.
tires are broader and we have 4 tires because they increase the area of contact with the ground and reduce the pressure and thus reducing the pressure exerted on the ground.
Hmm.
Next question. It is easier to ski over fresh snow. Give me the reason. Why is it easier to ski over fresh snow? Any idea?
No.
Fresh snow is softer and smoother compared to ice. Thus, the friction acting on the snow is smaller compared to the ice. Okay? It
Yeah.
is softer. It is smoother. There is less friction. Next question. The bodies of deep sea fishes burst when brought up to the surface. Why?
Deep sea. Because of water pressure.
Water pressure or body pressure?
Because of in deep sea there's a
More pressure,
uh,
more water pressure,
yes,
and
and their
body pressure is
body.
balanced. Yes. So at deep sea, pressure is very high, and fishes they are evolved to sustain that. So when they are brought to the surface, the inner blood pressure is too high compared to pressure outside, so it bursts their body.
Okay.